Hello friends, how are you? Welcome to Japan Study Center. Today we are going to see the chapter of geography and what is our topic today?
Humidity and precipitation. There is a most important chapter. The important point here of first, water vapor in the atmosphere. There is a most important topic, water vapor in the atmosphere. You know that water vapor is a highly variable component of the atmosphere, and it is a proportion to the various form of 0 to the 4% by the volume of the atmosphere. Water can be exist in the air in all the three states of the matter. The solid, there are ice crystal, liquid, droplet of water, and gases is the water vapor. There is the most important three state here: the solid, the gases, and the liquid. There is the most important here form. The most commonly water exists in the air as a tasteless, colorless, and transparent is a gas known as the water vapor. You know that what is a water vapor? The most commonly water exists in the air is a tasteless, colorless, and transparent is a gas known as the water vapor. The presence of the water in the atmosphere had made a life possible on the earth. There is a most important presence of water in the atmosphere has made life possible on the earth. Let's us examine to the significance for life on the earth. There is a most important point here. We have noted that in the lessons 10, water vapor is their atmosphere is absorbed in the significant protection of the both incoming solar energy and outgoing earth radiation. In this way, it is a present of great loss of the heat from to earth as a surface and help to the maintenance of suitable temperature on the earth. There is an important point here. I repeat again, we have noted that the lesson 10, that is a water vapor is atmosphere absorbed the significant protection of the both incoming solar energy and outgoing earth radiation. That is the most important here and the balance. And second point, the amount of water vapor present in the air affect the rate of the evaporation. There is the most important here, amount of water is a vapor present in the air affect the rate of the evaporation. There is some important. And third point is also here important. The amount of water vapor present in a volume of air decided there is a quality of the latent heat or the energy stored in there is a producing atmospheric change. There is important the amount of water vapor present in a volume of air decided there is a quality of the latent heat or energy stored in it from a producing atmospheric change. The next fourth air, the amount of water vapor present in the air of the place or inhabitants indicate their potential capacity of the water air from a precipitation. That is important. The amount of water vapor present in the air also affect to the standing crops favorably is on their other hand to the hot dry winds and damage to standing crop as in the case of rabi crop of north west India. That is important. And the sixth point here, the air poor in there is a water vapor content make our body skin dry and the rough. There is important here, sixth point, air poor in the water vapor content to make our body to skin dry to the rough, and it is because of this fact that we use of cream to protect our face from a dry air of cold winter to hot summer. That is important. The most important fact here, the water vapor present in the atmosphere absorb of radiation, control the rate of evaporation, release the latent heat from the weather change, and decided their potentiality for the precipitation. And in fact, standing crop and the our body skin energy is of the great significance. That is important here. The next topic is the humidity. Humidity is the most important here. How does the water changing into the water vapor? There is an important question here. The heat energy radiated from to the sun change water into the water vapor. And this invisible water vapor present in a gaseous form in the atmosphere. At the any time and place in the term is a humidity. In other words, we can say that their term humidity refer to the amount of the water vapor present in a given air. It indicates their degrees of the dampness or the wetness of the air. That is important, dampness and wetness of the air. Humidity of the air is mainly expressed in the following two ways. There is the most important two way here. The first here, absolute humidity and relative humidity. There is the most two important humidity here. The first here, absolute humidity. Absolute humidity is the ratio of the mass of water vapor, and actually in their air is to a unit mass of the air including the water vapor. It is expressed in a gram per a cubic meter of air. For example, if the absolute humidity air is a 10 gram, it means that 1 a cubic meter of that air hold of 10 grams of moisture in form of water vapor. Absolute humidity is variable and change from place to place and with a change in the time. That is important for absolute humidity here. The ability of the on air to be hold of water vapor depend about the entry on their temperature. The capacity of the holding water vapor of on air increase with the increasing in the temperature. For example, at a 10 Celsius, 1 cubic meter on air is can be hold of 11.4 gram of water vapor. It is the temperature of the same air increasing to the 21 Celsius. The same volume of the air can be hold 22.2 grams of water vapor. That is the most important and understanding here the figure the next and show the relationship between to the temperature and the maximum amount of water vapor that an air can be held at the given temperature. A cursory glance at there is a figure indicate how do the water holding capacity of the air increase with increasing in the temperature. Change in the temperature and pressure condition of on air result in the change of its volume and consequently there is a change in their absolute humidity. That is important. Hence there is a need of the some more reliable measuring of humidity. That is the most important here and the next here diagram. In this figure, show the maximum absolute humidity for the wide range of temperature. You know that there is show the minus 40 Celsius is a 0 degree. That is important here, and there is an increasing to the time and the at least is a gram per second. There is the most important maximum absolute humidity and there are wide range temperature on this figure. The next here, relative humidity. There is the most important point, relative humidity. Relative humidity is the most important and reliable measure of the atmospheric moisture. It is the ratio of the amount of water vapor actually in a volume occupied by their air to be amount of the space could be contained at a saturation. There is important relative humidity here. Here show the most important here formula relative humidity here. The formula is the relative humidity is equal to the vapor pressure in the air and saturation vapor pressure is the most important here. From the figure 12.1 it is quite a clear that air can be held a defined maximum quantity of the water vapor at the given temperature. And when this situation is attained by BS that air is fully saturated. The temperature at which a given sample of the air become fully saturated is called the Gibbs point or the saturated point. The relative humidity of on the air at the saturation point is 100%. Since the concept of relative humidity is very important in understanding this lesson, let us illustrate it is with the help of the example. That is important. The example here it is clear in the figure 12.2 that is the air can be held up 22.2 per gram of water vapor at their 21 Celsius temperature. If this air is holding to the 11.1 grams of water vapor at the same temperature is 21 Celsius. The relative humidity of the air will be 11.1 is upon 22.2x into 100 or the 50%. The 50% is the most important here. And if there is same air is actually holding a 22.2 grams of water vapor at 21 Celsius. The relative humidity of air will be 22.2 upon 22.2 into 100 or 100%. The air becomes saturated when it is a relative humidity is a percent is the more important here. If the relative humidity of the air is less than 100%, the air is said to be unsaturated. That is important here. The air becomes saturated. It is a relative humidity is of a percent, and the relative humidity is increasing. Then the temperature of the air goes to down or when to the more moisture air is added to it. The relative humidity is decreases Then when there is a temperature of the air increasing or when to less moisture air is added to it. That is important here. In order to make it clear that relative humidity is a better measurement of water vapor in the atmosphere than the absolute humidity, yet another example can be cited to the suppose there is a tumbler is containing 250 grams of water. One cannot be tell how much a portion of the tumbler is filled with there is water till one known it is a maximum water containing capacity. When one is come to know that is a tumbler can be contained to the maximum of 500 grams of water, one can immediately tell that is a tumbler it is a half filled with the water. Likewise, if one measuring a relative humidity of on the air, one not we only need to be now about it is actually water vapor content, but also it is a total capacity to the content to the water vapor at that temperature. So now you can be understand why the relative humidity is a more is a useful in making to the predictions about the atmospheric condition. That is important here. Here the most important point here arrive the absolute humidity is the actually amount of water vapor present in the gram per cubic meters of a given air. And the relative humidity is that ratio of the actually water vapor content to their maximum moisture holding capacity of on the air at the given temperature. And it is expressed is the percentage the RH is equal to the A dot H is the maximum capacity into 100. That is important here. The temperature at which a given sample of the air become a fully saturated is called dew point or saturation point. That is important here.